Hey guys, welcome back. In this video, I want to talk about oxidation-reduction reactions, also known as redox. Basically, this is the basic concept behind like when you have an acid and then you put, for say, a metal in it, and it like dissolves it, right? It like corrodes it, or like why iron rusts in air. Okay, so that's what we're going to be talking about. So basically some terminology, or some basic concept actually, I think would be better. Say we have our atom, and we have our dots, whatever, and we have our electrons. Okay, we have our electrons. If an electron is lost, an electron is ripped off, then that is called oxidation. Okay, it lost an electron. Okay, but if an electron, well, actually, let me explain a little more. If it's oxidized, then it becomes positively charged, right? It lost an electron, so it's now plus, so it's a cation. Okay, so, and if it actually gains an electron, okay, let me redraw that one, and it gains an electron, then it's going to be negatively charged, and it's an anion. Okay, and then that process of gaining an electron is called reduction. Okay, so this is kind of counterintuitive because it says reducing, but it's gaining, right? Because it gained an electron, but it's reducing it. That's kind of like opposite, you could say. So there's just different ways to memorize this. Maybe remember, oh, it's the opposite, or remember one way that my teacher actually likes is that if you have the charge, your charge is 0. If you gained 1, then now you have a -1 charge, right? So you reduced your charge, which makes sense. Really, personally, I just memorize it, okay? But that's something that you need to know. Moving on. So, oxidation-reduction reactions. Which atom, which element takes which one? Like, say for example, you have acid, HCl, okay? You have your acid, and you put in iron metal. What happens, right? Okay, well, what is needed in this case is something that you're not expected to memorize. I don't know how well you can see this. Is an activity series table, and in this table it lists the elements in order. In let me give you an example. In this case, we have a hydrogen ion, okay, and it is located above or below. Let's see. Iron. Let's see here. Iron. Sorry about this, guys. Iron. It is located below. Okay, so iron in this case will not rust. It will not be dissolved. Okay, because the iron was in this case above it. Okay, so think about it like this. This here can be ignored. Okay, because the acid is just going to dissolve in the water, as we know, and this is a plus. So this is the ion, and this is the ion you look for. Okay, and in different cases, in different tables, sometimes it will be in this order, sometimes it will be upside down in the opposite order. So you just have to know like which ones will like react and which ones are like inert. So basically you can look for gold, and gold in this table is at the top. Okay, so the higher you go up, the more inert it is, the more unreactive it will be, the more it will retain its electrons. Okay, so that's what I look for. So in this case it's up, and because this is above it, this will retain its electrons. Okay, but now in the case, let's give an example of where we have zinc. Say we had zinc. Okay, let's say we had zinc. Zinc is below it. So what would happen here is it would go H plus plus zinc metal. It will go to Zn 2 plus plus hydrogen gas. Okay? You would actually need 2 of these. Alright? So this zinc lost 2 electrons and gave it this way. This zinc was oxidized. It lost oxidation. And this hydrogen was reduced. Okay? Reduction. It gained them. And you got zinc ion and hydrogen gas. Okay? In this case, it's hydrogen gas because hydrogen, you're not going to have monatomic hydrogen. Okay? You're going to have diatomic. That's just the nature of hydrogen. If it was something else like, let's see, if it was cobalt, let's say we put in cobalt, then it would have been just CO. Okay? But hydrogen by its nature, it's diatomic, so it's going to go to H2. Alright? And that is basically oxidation reduction. I think that's all I want to talk about. And that's about it. Alright.